Our third class of reversible inhibitors is a slight modification of the type examined in our previous lesson. Similar to a true noncompetitive inhibitor, a mixed noncompetitive inhibitor can bind either the free enzyme or E form or the ES complex. So again, multiple equilibria occur. The distinction is that a true noncompetitive inhibitor does not influence the substrate binding affinity. The mixed inhibitor does. This means that the affinity of the free enzyme 4 inhibitor, represented by the constant Ki, is not equivalent to that associated with binding to the ES complex, the Ki prime constant. As with the true noncompetitive inhibitor, the mixed inhibitor also lowers Vmax. Let's take a moment to remind ourselves of the Lineweaver-Burke equation and plot in the presence of a noncompetitive inhibitor. It increases both the slope and the y-intercept, but does not change the x-intercept. A mixed noncompetitive inhibitor likewise lowers Vmax, so it also will increase the slope and y-intercept. However, a mixed inhibitor does change Km. The Lineweaver-Burke plot does look very similar to that of a true noncompetitive inhibitor. That is, both the slope and y-intercept have increased in the presence of the inhibitor. However, since the x-intercept is the negative inverse of Km, if the value of Km increases, then the x-intercept will become a smaller negative number, moving closer to the point of origin, just as we see here. Perhaps I might mention that a mixed noncompetitive inhibitor always alters Km. Most often it results in reduced substrate affinity and therefore a higher value for Km. In some cases, though, it might actually lower Km. Nevertheless, it always lowers Vmax and therefore negatively influences enzyme activity.